This lesson covers Hyper-V networking. For our virtual machines to be useful, they need to be able to communicate with each other and communicate with machines outside of the Hyper-V host itself. To accomplish this, we have Hyper-V virtual switches. During the installation of the Hyper-V role, we were given the option to automatically create an external switch by specifying a network adapter. I turned this down in the example so we could do it manually. Through the Virtual Switch Manager, we can create one of three different types of virtual switch. An external virtual switch, as the name suggests, actually maps to a physical network adapter. This then allows that virtual switch to pass traffic from the Hyper-V host to the external network via that network adapter, giving virtual machines external connectivity. It is important those virtual machines have IP configuration that matches the IP scheme that network adapter is actually connected to. Also, the option to allow the management operating system to share this network adapter is available. This means even though the network adapter is now being used by a virtual switch for primarily virtual machine traffic, a virtual network adapter is also created on the host operating system, so the Hyper-V host can continue to access the external network through that same network adapter. This would be useful if maybe you only had one network adapter in your host, or maybe you had multiple network adapters but you teamed them together into one highly available load balanced team. If you have separate network adapters for the VM traffic and management traffic, you should unselect this option. I can also do this through PowerShell. I can get a list of all my network adapters using the get netadapter command, and then I'm going to create a new VM switch called external switch. I can give it some notes, tell it which network adapter to use, so this VM NIC, and I'm going to tell it not to allow the management OS to use it. This switch will now appear in the Hyper-V Virtual Switch Manager. And there it is with those configurations I configured. An internal switch can also be created. But before I show you that, if I now go back and look at my VM NIC, it's actually been unbonded from all network services except the Hyper-V Extensible Virtual Switch. It's no longer having native TCP/IP or any other client services, it's just being used by that Hyper-V Extensible Virtual Switch. I can create an internal virtual switch. An internal virtual switch is visible only by the Hyper-V host and the virtual machines. This allows communication between the host and the VMs and between the VMs themselves, but it does not map to a physical network adapter, so therefore has no external connectivity. Once again, I can create this with PowerShell. With an internal switch, I'll now see a new network adapter created on the host, which is how it will actually communicate with the VMs, and I would specify IP configuration, etc., like any other NIC. But remembering, it's not using external connectivity. This would be static IP configuration between the host and the VMs, unless one of the VMs was actually running a DHCP service connected to that same switch. I can also create a private switch. A private switch is the same as an internal switch, except that the host has no visibility. So it's only for VMs to communicate with each other. You'll notice I have no new switches created when I created that private switch. One nice feature is I can actually create additional VM network adapters on the management OS itself. So whereas I had that option to allow the management OS, I can actually create many different virtual network adapters on the parent partition on my actual host OS using one of the network switches or any of them. I can create many of these devices. So if I create this new adapter, what I'll now see is that extra virtual NIC, and I can now use that through the switch. And likewise, I can remove it. I can get a list of all the different VM switches available through PowerShell. So that's just showing me the external ones. If I use the hash or the pound to comment that out, then I'll see all of them. Likewise, I can easily remove. If I use the whatif command so I don't actually delete them, you can see that would quickly remove all of my adapters. Now the virtual machines themselves have one of two types of network adapter. If I navigate over to one of my other Hyper-V hosts and look at the properties of a virtual machine, you can see I have a network adapter. This is a synthetic network adapter, which means it knows it's virtualized. It's an enlightened operating system, and it realizes that network adapter is actually virtual over the VM bus, which is how Hyper-V communicates between the parent partition and the virtual machines. It's a kernel level memory bus. It's very, very fast. And this is what you always want to use if you can. This is the fastest type of communication. But if I have a non-enlightened operating system, it's not supported by Hyper-V integration services, or I need to boot over the network. You cannot PXE boot, i.e. boot from the network, from a synthetic network adapter. You need to add a legacy network adapter. And this actually emulates an old Intel network adapter and would therefore be able to boot over the network. So you have these two choices in the type of network adapter you can create in a virtual machine. Each VM can actually have up to 12 different virtual network adapters, 8 synthetic and 4 legacy. And for each of them, you specify what it connects to. There is another type of network connection available. When I actually have advanced new servers with the newest type of networking equipment and motherboards, there's a technology called SR-IOV. SR-IOV allows the network adapter to actually pretend it's many network adapters. It creates virtual functions. And these virtual functions can then be mapped to specific virtual machines, and it then bypasses the virtual switch altogether. This gives you the highest level of performance and zero latency, but it means it is bypassing the switch, which means you can't take advantage of any of the switch functionality. The Hyper-V switch is now extensible in Windows Server 2012, using existing APIs such as the Windows filtering platform and NDIS. Third parties can create plugins for the switch. For example, a plugin for traffic trending analysis could be created, and actually does exist. A firewall could be created. Malware protection. Cisco will have a Nexus 1000V for Hyper-V, allowing full virtual network management from the same tools that are used to manage the physical network fabric. So a lot of flexibility in how the network management is actually performed. The key part though is if you require the virtual machines to be able to talk to the external network, you're going to have to create an external type virtual switch, and you're probably going to leverage NIC teaming. So you would create a NIC team on your Hyper-V host with multiple network adapters, which gives you resiliency and a higher bandwidth, and then map the virtual switch to that NIC team. This concludes the lesson on Hyper-V networking.